Verge, we are here back for AP Calculus AB yet again.
Hey, Mark, good to see you. Good to talk to you. Good to hear your voice.
You're not tired of it after 2 weeks of this? All right.
I'm not keeping track of time. Well, I kind of am actually, but we got our introductions again. Go ahead, Mark.
Hi. Excuse me. little coffee. I am Mark Corrali. I teach at Ryan High School in Denton, Texas. And
I'm Verge Cornelius. I teach at Lafayette High School in Oxford, Mississippi. I can't remember if it was a student or a teacher who emailed me yesterday and said, "You don't sound like you're from Mississippi." And so I think we need to clear that up because neither Mark nor I are actually from the places where we've lived for the last 20, 25 years. So here's a big shout out. I am from New York. I'm from Manhattan. Yeah. Yeah. I'm with you, New York. I love you. I'm very worried about a lot of my friends and family that are still there. Go ahead, Mark. Where are you from originally?
I am from Michigan. I'm from a small town outside Detroit. It's Northville, Michigan. Points if you know that one. Livonia, Plymouth, Canton area. So shout out to them. My sister's still up there. And of course, they just announced today they're out for the rest of the year. So hopefully we're helping a bunch of students back in my home state of Michigan as well. Although like Verge, I've been in Texas now, just over half my life. So.
But I've been in Mississippi.
I love my Texan students too. Hello, guys.
Okay.
Right. That's enough of introductions.
Enough.
Okay, so where are we going today? We are finishing differential equations today and tomorrow. That was this week. We are going to next week talk about selected topics of application of integrals, which is unit 8, and we're going to tie that back to some previous units because we do realize you guys are focused on those exams that are coming up. And then we begin our extended review the following week of all our 2020 tested topics in addition to test taking strategies. And hopefully we'll have some more information for you guys tomorrow or Monday about exactly what to expect on the exams. Hey, Verge, that's the same picture as yesterday.
That's right, because we are now 2 consecutive days without incident.
Yay.
So yay. And we still look younger and my hair is shorter. I haven't had a haircut.
And there's a little Michigan State shout out for you as well. All right, so today covered our introductions and corrections. We will have a warm-up. I believe, Verge, I believe you're going to work the warm-up?
Yes, I am.
And then we will walk you through 7.8 exponential models with differential equations. And we'll
Hey, Mark, I'm still seeing the other screen. Are you sharing the next one? Okay. Yep. Okay.
Oh. All right. I am prepared to go solo today. I think Verge is having some internet issues again.
Sorry.
So I don't want
and I'm hard connected too to all the tech people on the backside.
Don't want to, but I'm prepared. And then we will wrap some guided practice into that lesson, and then we'll wrap up and let you know those items that are in the Dropbox already, what exactly those entail, especially the second one. You might want some direction. And I think we just lost Verge. Oh, she's back.
Hey.
Did you drop out for a sec? No. Okay, so it looks like I may be going solo here.
It's okay.
Okay. You're frozen on me. I don't know what's going on. I don't know, back screen person, if you can give me an idea of what's happening. Oh, there's Verge moving again. All right, I'm going to go ahead and steal the screen. And sorry about this. All right, so our warm up. This is taken from the first page of that differential equation circuit that was in yesterday's Dropbox. It says find the particular solution to the separable differential equation without the aid of technology, which is pretty much how we've been going all week. And good news for those of you that have missed your calculators, we are going to touch the calculator a little bit later today. So I'm going to steal this. In our original problem, I'm going to rewrite this for you, was y prime is equal to the opposite of 4y. And we were given this initial condition using function notation y of 0 equals 8. And again, I generally just rewrite that as 0.8 immediately, just so that I have an idea of what I'm looking at. Likewise, that y prime, just a reminder that y prime is our derivative with respect to x. Although, if you look at this problem, there is no cue anywhere that that is x. A g, or they didn't tell me what my independent variable is, so I can actually pick whatever I want. I'm a traditionalist. I know many of us, I'm much more comfortable with dy dx or dt. I suppose I could do dy dg there if it turns out that y is a function of g, or there's some kind of contextual information. But without that, we're just going to go ahead and pick x. All right, I'm going to separate my variables. So again, I'm going to do my differential of y, or dy, is equal to 4y times the differential of x. And then I'm going to bring the y over, but I'm going to leave the 4 on the right. I'll pull back my camera a little bit. And I know Verge even mentioned yesterday. Oh, you're still seeing the slide, it says. I am so sorry. Thank you for the information. All right. Okay, so sorry about that. You got to watch a lot of me looking down at the slide. Y prime is equal to the opposite of 4y. Again, dy dx is negative 4y, and I just chose this because I wanted to. Got my initial condition. We have separated. Welcome back, Verge. Verge is muted. Dy is equal to the opposite of 4y dx, and I've moved this y over, and if you prefer that as 1 over y dy, that is perfectly okay. I just like it nice and clean like this because I can recognize that as an impending natural log. I'm going to take the antiderivative of both sides. I'm going to get the natural log of the absolute value of y is equal to negative 4x plus some unknown constant c. And my absolute value of y there, I'm going to try and isolate that. Although let's go ahead and bring in this 0.8. And I like orange. We're going to switch over to orange. Verge, can you hear me okay?
I can actually even switch to my screen if you want. I don't know what is going on with our service today, but I am more hooked up than there's wires everywhere and everything's connected, and I don't know why. It's got to be the internet provider.
It is up to you if you'd like to take it.
Okay.
I am a
So
good
you
ways
just found natural log of 8 is equal to c.
Right.
And I need to have co-host permission. I don't have that yet.
So while you get co-host, I'm going to just go ahead and start writing the next line. And it looks like you should be able to take it.
Okie dokie.
And I see, there we go. Hey, it's Thursday.
Yep.
And once again, proving we're live.
So here's my work, which is going to look really similar, except the color is different than Mark's. And he was down here at this natural log of 8 is equal to c. And then substituting back in, e to the natural log of the absolute value of y equals e to the natural log of 4x plus natural log of 8. And then the reason we exponentiate is so that we can go ahead and free up that y. So we have absolute value of y is equal to 8e to the negative 4x. Y is equal to plus or minus that. And then we pick the positive branch because we want that output to be 8 when the input is 0. So that ends up to be the solution to our differential equation, the particular solution, I might add.
Awesome.
And I think where this lesson is going, and luckily considering my internet situation, I guess, this lesson is kind of going in this direction. And so as we think about where we're going, I might, as a mathematician, look at this equation and look at my given information and realize that if I understand what just happened, I might be able to be more economical in my steps. Let's just put it that way. Go ahead, Mark.
All right. So I guess I'm going to steal your screen back one last time, or at least for a little bit. And I've got mine back.
Mm-hmm.
Okay. So, um, so what we want to talk about today, and this is going to relate a lot to past courses for you, and what Verge has, she said it the first day, and it just rang with me that first day, is we are looking for patterns in mathematics a lot. And so you may recall in Algebra 1 and Algebra 2, you learned how to complete the square and have found some uses for that since, I hope. In fact, we can use it to integrate, which we'll talk about during our review sessions in a few weeks. But we ended up going with the quadratic formula, which is just completing the square in a general form. So I'd kind of like to do a general form because we've seen this before. Verge, remind me with this problem, what is the variable on the right?
The one that we just did,
The one we just did, yes.
Okay, so it was dy dx is equal to negative 4y.
Okay.
Uh-huh.
And so what is the role of that guy? What is the role of y?
Well, you mean in this differential equation?
Yeah.
Well, I would name it as the dependent variable. That's how I usually discuss it. So I'm seeing a differential equation with only the dependent variable showing.
Okay. And we see this a lot, and you saw it a couple times in the circuit that I gave a couple days ago and Verge's circuit yesterday and in the practice, where we've got this constant times our our dependent variable, our variable that's in the numerator of our differential. So you got a letter you want to pick for me, Verge? Just give me a constant.
Any old constant?
Any old constant.
Okay, so dy dx is equal to M, capital M.
Ooh, capital M. I like capital M.
Capital M.
So if we
And
had
then
something
Y.
like this, and one of my friends sent me these pens with this eraser. It's so cool.
Guilty.
Yep. So we have this dy dx equals capital My or mu y if I move it down a little. But this idea that the rate of change
that would be the dy dx, yeah,
of y with respect to x is, and then how do we deal with this equals a constant? Is proportional.
Oh, this is reminding me of the very first day.
Yeah.
Mm-hmm.
To our y, to our function value.
Mm-hmm.
So the more y I have, the faster this is changing, and the less y I have, the slower it's changing. So we are going to try and come up with a general solution for this and then relate that to a particular solution. So I guess we need a point. What if we had a point?
How about having, 0, comma, capital B?
Okay, so we're going to, when we start, we have b. Y has value b at time 0. And if we steal that function notation from the previous. So I'm going to go ahead and do my separation. We're going to do dy over y and capital M dx. You'll notice this looks very familiar. But can't use the same colors because I used purple as my integration on the last one. But we will integrate, and we're going to get our natural log of y equals mx plus c. And wow, there's a lot of letters in there. I don't know if I can remember the name. Actually, I think I do, and I think we got our dinner from the restaurant her dad owns last night. One time when we were doing implicit differentiation, I had a student look at the board and just say, "I miss numbers."
I was just thinking the same thing. That
this
I
does
see
remind
0.
Me of I know there's a 0. There's a very significant number right there. All right, I'm going to exponentiate.
Mark's working, and I just want to make a little commentary here. This is really justification. Like, this is doing a proof of the fact that we can have this general result, irregardless of any kind of numeric values going on. We're able to completely generalize here. So he's doing the same thing.
Yeah. So I use my exponential on each side, and we've got the absolute value of y now. And again, when we're adding exponents, we get to multiply again. I promise my kids every August that by the end of the year, even if they don't really understand what's happening in my class, their algebra skills are going to be fabulous. And if any of you have younger siblings in Algebra 1 or Algebra 2 at home and you've been helping them, I'm sure you're surprised at how easy it seems. So I do remember from my algebra courses that when I'm adding exponents, I'm really multiplying. And this e to the c here is going to equal some other constant, which I'm going to call big C for now. Obviously, I just switched from lowercase to uppercase. And at this point, I kind of want to find out what that C is. So I'm going to come down with my initial condition. And I'm going to get rid of that Y first, that absolute value. Let's go plus or minus C. Because how am I going to decide on that fork?
Well, you're going to think about input output. That's how I always do it.
Mm-hmm.
You're going to slide your paper up just a little bit.
Thank you.
Mm-hmm.
That's always the front row person's job in my class and my workshops. So we have 0 times m, e to the 0 is 1. So this is just c times 1. And now this sign is going to be determined by b. So realize that b is just a non-zero constant. So my final answer, my y is equal to be to the m times x. And now, where did this b come from?
I know.
Where did it come from? You in the front, Verge.
Okay, so actually that was the initial value, the 0, b.
Awesome.
Mm-hmm.
And this m up here,
that was that growth rate. I don't know. Yeah.
The
I'm
proportionality
okay to say,
constant.
Yeah, the constant of proportionality, exactly.
Which, now both of these, obviously we use some other letters for in tradition. So I'm actually going to pull up a new slide. We kind of briefly talked about what we're doing today. But this is our 7.8 exponential models. And notice what the skill is. Verge, you're so ahead of the curve.
Yeah.
It's
so justification. Yep.
And right down here, this skill is really what we're focusing on today, that if dy dt is the product of some constant k and y with an initial condition of y is y naught, then why not? Then when t equals 0, this will have the solution of the form y equals y naught times ek. And a lot of times you see this with ce to the kt and things like that.
Or even PERT back from algebra 2
Yep.
or pre-calculus. PERT PE to the RT is the same thing.
So this is our old continuous interest rate function, half-life, which I'm just going to use the lambda t, and you can define lambda in different ways involving the natural log of 2 and things like that. Any growth rate decay, if you can think of any growth rate going on, this exponential may be at least locally happening when there's no restrictions on the growth or no restrictions on the decay. So pretty cool stuff. But the significance of that other slide is these do show up, they are common. And because of that, making that connection and that general solution, just like if I have a quadratic form, when I have a quadratic formula, I don't have to justify the quadratic formula every time I use it. I'm allowed to just say, hey, this is quadratic formula. So every time you see this relationship, this rate of change of y with respect to x is proportional, or this starting point, you can jump all the way down here. I was looking at the screen instead of my paper. And you can jump to this general solution. Of course, this does not need to be as many lines as it is. We're doing this very drawn out the first time. You start the process, you can do it in 4 or 5 lines, no problem every time you need it. But you are allowed on the free response, and obviously in the multiple choice portion of an AP Calculus exam, to jump from this relationship to this relationship. And that's what we want to take advantage of today. All right.
So if you're watching live or if you're watching at home, we do have some materials that Mark is going to lead us through that are in the Dropbox. They are some practice problems from AP Classroom. And we're going to do them in, I believe, in order of 2 and then 3 and then 1. Am I right about that, Mark?
That is correct. Okay. And there are 6 total. So there will be 3 for you guys to practice on your own.
Yeah, and the answers are going to be there as well. So
The answers are hidden at the bottom upside down like a good puzzle. So.
And again, we know that multiple choice is not on this year's AP exam, but these are still such rich problems that we definitely wanted to use them in our instruction.
Yeah, especially the second and third examples we're going to do could very easily be open-ended as well. Also want to say these say they're adapted from AP Classroom. I may have changed the answers. If you didn't notice, sometimes on AP Classroom, you'll see two very similar problems and the answer choice is the same each time. I'm sorry if I'm ruining those quizzes for some teachers right now, but I think the brighter students who are our students have already realized this.
Yeah, because patterns.
Yeah, because oh yeah, we're training you to find patterns, and so let's look at number 2, and this is it's a kitten. I love kittens. A kitten weighs 85 grams at birth. During the first 4 weeks after the kitten's birth, its weight in grams is given by the function w that satisfies the differential equation dw dt is k times w. Remember, that's where t is measured in days and k is some positive constant. That's good. That means the kitten's actually growing. Which of the following could be an expression for w of t? So let me grab my favorite of these colors for some reason. I like this blue. Maybe because it matches my sky background today. Also, I should probably scoot that over in case my picture's not over that. So what do you notice about this? Since Verge is my only student, I'm going to call on her again. I know there's some people in the back that really wish I would call on them, but
even though the variables are different, the form is the same. It's just like the dy dx equals, you know, m times y or whatever we had there. So
yeah, we're still the weight of the kitten is changing at something proportion to the kitten's current weight. So as the kitten gets more food and more weight, it's going to grow faster. Now, obviously, this is during the first 4 weeks. So these are local a lot of times, because if the cat kept growing at that rate, we'd eventually be able to be on Netflix.
oh boy, I've
Yeah,
been watching that too. That's a crazy show.
All right, so I can go through this separation, but what this unit is about is this: we've already justified it, so we're allowed to jump to the solution. I know w has got to be of the form w naught e to the kt, and they actually gave us w naught. Whoosh. That is w0.
That's the initial weight of the kitten.
That's right. And so we come down here and look at our choices, and we actually don't have enough information to find k. What would I need to find k?
You'd need another measurement. Like when I do these in my classroom, a lot of times I do Newton's law of cooling type problems where there's an initial measurement and then another measurement like an hour later. So you'd need another point on the graph, another weight of the kitten at a different time besides 0. Like after 1 week, how much did the kitten weigh?
Right. In fact, if they don't give you the initial, but they give you 2 data points, a lot of times, just like we can find slope with 2 data points, you could use 2 data points and create a system to find the initial. But
yeah, or you could do a horizontal shift.
That's much more the type of thing we do with pre-cal or algebra 2, right?
Yeah.
Okay, and this goes through the point 0.085. I think if you check all these, they all go through the point 0.085, but only one of them matches this exact format.
Mm-hmm.
And that would be D.
Yep. Good. And also, just understanding in terms of that rate of change that you have that exponential model, you can immediately rule out the quadratic. I mean, throw out the A.
Yeah,
for sure. Yeah, it's easy once you understand it, but at first you don't understand it.
Right, and this one's a decay as well, not to mention this shift, but
yeah. Okay, so 3 next.
Number 3. Number 3's got a little icon.
Good job on that, Mark. He made that himself.
I am one of those people that was really upset for 15 minutes a couple of years back when they said they were going to take MS Paint out of Windows. Then they said, okay, you people that are stupid and won't learn the new one, we'll leave it in there for you. Me and my brethren went, yes. All right. So I do have my handy calculator right here, my TI-84. My Inspire and my Casio and a couple others are all sitting in my classroom or verboten. So, but I actually am I think I'm gonna pop out and do Desmos in a second for some of you so that we can just quickly talk about other options. I may not show it, but we can at least look at mention that you have other tools out there. There are also a lot of online calculators have made themselves free during this strange time. All right. We have extreme heat applied to the colony of microorganisms causes the size P of the colony measured in grams to decrease according to the exponential decay model dB dt dP dt. Wow, this gets tough to say. Is equal to -4/10 P, where the time T is measured in hours. The size Q of a second colony of microorganisms, also measured in grams, decreases at a constant rate of 1 gram per hour according to the linear model dq dt equals -1. So they gave me the information I needed to write each of these, but then they did give me my differential equations. If at time 0, the first colony has size P of 0, or population at time 0 is 2. And the second colony has size Q, which is just a misspelling of population, I suppose. I think they went alphabetical. Q of 0 is 3. At what time will they have the same size? So there's a lot to digest here, but I'm just going to go and say, all right, they gave me a differential equation here. And what form is that equation?
That's definitely exponential. It's the exponential model.
Yeah, that's our k times y with dy dx, or, in some form. So I can jump down and say, all right, P is going to equal P naught e to the -0.4 t, because that 0.4 is playing the role. Oops. These are erasable. That's so cool. All right.
I know.
Although I took some toner with it.
Yeah, when you erase actually on a handout or something like that, it does smudge up your.
All right, and we know P naught, right?
Yes,
that's
we know
2,
that's
so.
2.
Okay, so we have our P. And if I was doing it in chalk, I do it in yellow because I'm a child at heart. Whenever I find P, I use yellow chalk because I'm 12. All right. So dq dt is equal to -1. I can integrate that.
You can also understand that it's linear.
Yeah.
Sorry.
No, go ahead. Yes, this is absolutely
this
a
is
slope.
linear. So that's telling me that I have a slope. They also gave me my y-intercept because they said that Q of 0 is 3. So you don't have to do calculus there per se.
Exactly. Yeah, this can absolutely happen here with, it's a line. All right. And then I did use my integration of constant this time as mt plus b because it's a line. And my m is -1, and my b is going to be 3, because if I come over here and do, oops. You'll also notice I try to write over first. I forget they're erasable. There we go. So Q is -t plus 3. And I'm going to try to stay away from that pink again. I think that's a little light. I apologize.
I can totally see it.
But for people that are watching these on phones, I need to keep that in mind. So, all right. So here's my handy dandy calculator. And I want to know when they're the same size. So what am I really looking for?
Intersection.
Yeah, I'm looking, when is P equal to Q? So I'm going to come in. Oh, these are, hey, look at that. Oh, my daughter must have been playing with my calculator and typed these in earlier.
No, actually, we plan these lessons, right?
All right.
This is the turkey coming out of the oven.
Now, yes. Hello, Julia. Now, what was not intentional, but I am so happy, is notice the colors.
Wow, that's really providential.
So I hit my graph. And there's clearly an exponential curve. Hopefully a line comes. Oh, they hit twice. So at some point they had the same negative at some negative time they had the same population. If these were continuing for a while, sometime before they started measuring this, they may have been, but they do say at time 0 heat is being put on this, so the model really doesn't hold probably to the left of 0. But I certainly want to know when they're going to be the same at a positive time. So I'm going to go, I want to calculate something. I'm going to go ahead and slide this up. So I'm going to calculate on my menu, and I want to calculate an intersection. And I'm going to drive over to that point. So my first curve is the exponential. Second curve is that linear, negative x plus 3. Also, yeah, do notice that up here, I did spell it with an x. I mean, clearly these are t's, but if you tilt your paper, it can be an x. It's a common math teacher thing. And S doesn't really matter. And my intersection, and I'm going to write this as if it was free response. I know I've got some choices over there, but at time t equals 2.1555, so I could write that as 5.6 or 5.5 on an AP exam. And my units are hours. So at time 2.1555 or 5.56, sorry, let me just say, I'm going to write it down because I'm doing a horrible job of saying it out loud. At either of those times, they have the same population. And specifically here, they asked for the time. But what I would do is just for completeness, say P and Q are both 0.844 grams. Is that right? Yeah, grams.
Yep.
And that way I've answered the question no matter what they asked. They said, what population will they be the same, or at what time, or if they asked for both. I just feel that reporting both, if you're doing this as a science experiment and this was something legit in a lab, and you go back and you're a research assistant, you go back to your professor and say, okay, we got it at 2.156 hours, we're going to have the same populations. The obvious follow-up question is, well, what's it going to be? So I think reporting both is the most responsible thing I can do.
You know, this while we're talking about this brings up another point, and Mark and I are really more concerned about calculus for calculus's sake, honestly, as we're teaching and instructing. And these problems come up a lot in the lab, in chemistry and in biology labs. And so it's important to start understanding this model. Anyway, that's it.
No, that was excellent. All right. So get my hands ready, because now we're going to do some algebra.
Yeah, when I did this problem here, folks, it is a long one. My students always say things like, do I need to get another piece of paper right now? I'm like, yeah, you're going to need another piece of paper right now.
As scary as she's making it, I'm also going to give you guys a tip for college in the next, and I know we've got freshmen and sophomores and even some 8th graders occasionally calculus. But those of you that are probably on a college track, I am going to do a couple things in here where I may skip a step that you might not. That's okay, and that's going to happen in your college courses. You finish your notes at home. you write down the steps the professor did. You leave some spaces if you need to, or you recopy the problem. So I am going to take a few jumps in here just to make it fit in the space.
And also, Mark, you might scoot it over because of where your
yes, you're right.
Your head is. Yeah.
Yes,
we learned that yesterday. Thank you.
Yes.
Mark's
just
head.
Do that. During a chemical reaction, the rate of change of the amount of the chemical remaining is proportional to the amount remaining. And you notice they don't give us the equation this time, but again, I see this for the rate of change of the amount. And do they even give us a formula for? They don't give us a variable. So we could use C for the chemical. We could just use Y. Which one do you feel like using, Virg?
Well, I just wrote, it doesn't matter.
I did
I just hopped honestly straight to Y equals CE to the KT.
So you still did Y though. Yeah. And then proportional to the amount remaining. So, and Y is the amount of stuff. And there's my 2 Y's again. So yeah, we can jump straight to that, which that's the calculus part, is that recognition. And unfortunately, when we're in a multiple choice situation, I can't stop there. At time 0, so there's our initial. That's our big C, our initial. So we have 12e to the kt. And then some of you may even recognize this from pre-cal. I know when I taught pre-cal, we used to do these. So, and then I'm going to go find my k, which I go by Mr. K in my classroom. So this might be like, here I am. But we have 4 moles is equal to 12e. And which one is the 4 going into here? It's going
Actually,
into
both.
T, right? Well, no, I was saying the T or the K up in the
Oh,
accident.
yeah. We
I'll
have to
put
find
4.
the K
A
value.
lot of times I'll put 4T there on accident. All right. And this is where I'm going to skip a step because 4 divided by 12 is 1/3. And then I'm going to go ahead and natural log both sides. Right, that's not a big skip, but it's a little bit. And then that's the log of 1/3. And this is going to be 4K. And that only works if K is positive. Do they tell us K is positive? Okay, no, that's okay. I take that back. I never said that. That should have been edited. Don't worry about it.
But that's what we do. We think, that's
Yeah.
always in our mind is the thinking going on.
Okay.
Go ahead and push your paper up a little bit, Mark.
Thank you very much. So, and I said I wasn't going to use the pink, and there I am using the pink.
Whatever.
It's just so pretty. All right, so we divide by 4, we get 1/4 the natural log of 1/3. So I'm going to come back to my purple. And now my K, and honestly, if this was calculator active, I would leave that as a K and just use the K in my calculator. And let's put some grouping symbols around that to keep that K and T separate. And now they say, at what time T is it 3? So is that 3? These 4s were easy. I could plug them in together. Is that 3 a T or a Y?
Y. It's a Y.
So that's Y equals 3. T equals what?
Yeah, and yeah, I usually think also about, like it said, at what time. So I know T is what I'm looking for. So I know to keep that as the variable.
So once again, I'm going to go ahead and divide this. 3/12 is 1/4. I'm going to natural log both sides. So I'm dividing by the 12, if you want to put a thought bubble over here. And I'm doing a natural log. So this is just going to become 1/4 the natural log of 1/3 T. And this is where the algebra got fun for me. Of course, I have a different definition of fun.
Not than mine, though. Not than mine.
Right. And I could divide by a 4th. I guess we'll go ahead and show that. I am not a fan of dividing by a 4th because that's the same as multiplying by 4. So I'm going to put that 4 on top. And I still don't think I'm going to see my answer because all of these are just 4s and 3s. How could that happen? Well,
I know. If you want me to tell you.
You go ahead. Tell me, Virg. What do we know about 1/4?
Well, the natural log of 1/4 is the same as the natural log of 4 to the -1 is the same as negative the natural log of 4. I don't know if that's where you were going with that. Yes, it is where you were going with that. Okay. So then, same reasoning in the denominator. Yes. Yep. And so those negative divided by negative is a positive. And so then, yeah.
And then, so it's a negative 4 log 4 over negative log 3. And and I know if anyone's noticing, I just say log, and I'm just as biased to natural log as I am to radians. If I say log, I mean the natural log. I will say common log when I mean that thing that is related to these digits. So yeah, it's and then negative over negative is usually a positive.
Yes.
And I'm looking at D, which I believe is correct.
Yes.
And that's a lot of algebra. And that, I know there's always this issue of, hey, we're at home, we have these exams, we don't know what's going on. And the exams are not multiple choice. And so on a free response for AP, you can stop here and you can leave it like that. And I highly recommend that whenever we end up taking the exams. But you are going to college. You are going to be taking multiple choice tests in the future. You're going to have professors that want a cleaner answer. And so this is, practice that's worthwhile. It's manipulations you may use and other things. And honestly, like log properties and things like this, even if you don't end up going into a STEM field, at some point you're going to have, I need to show this, I know rules to get here, how do I make that connection? And so even when you're not playing with numbers, this type of puzzle work, as I think of it, is a really good thing to keep in mind. So.
Awesome.
Right.
So I think we're going to start wrapping up. We're going to talk a little bit about what's in the Dropbox.
Yeah.
So Mark will pull
So
up the
back to the
PowerPoint.
slideshow.
I didn't get my chance to tell the joke. I'm not sure if I'm disappointed about that.
Oh, I know we didn't get
that I
time to have
didn't
you
get
guys
a
work
chance
one on
to
your
tell the
own,
joke, but
these are pretty straightforward. So hopefully you get your.
well, the
prizes.
three that are in the Dropbox. So the what Mark was just working, there's actually 6 of them, and there's 3 that are in the Dropbox that we would encourage you to work on your own, and the answers are there for you to check. And then what else is in the Dropbox is something that I wrote several years ago. So some of the teachers and even students might be familiar with this activity, but go ahead. You want to talk about it, Mark, or it's what's showing right now?
Sure. Yeah, I was actually going to also say I did write new distractors and rearrange the answers. So the 3 problems that parallel those in the assignment are not going to have the same 3 answers necessarily. All right. So this card sort includes 12 cards total. We've got a preview of one down here. Don't squint. We've got it bigger on the next slide. And you're going to look at them and decide, are they independent variable only, dependent only, or independent and dependent? And you slide those in these slots right here. You don't have to print this page. You can write it down on a piece of paper.
And then you can check your work and make sure that you have it sorted correctly.
And the key is included. And then you'll work each problem as well if you're, it depends on how bored you are, I suppose. So here's what a card looks like. And Virgie, go ahead and walk through this.
Well, and I wrote this to help students really with that first process when they're solving differential equations to make sure they understand what it is they're looking at. So as I look at this card, dh dx is equal to, in parentheses, h plus 7 raised to the 3rd power. That's the differential equation. So the first thing I want to do is really kind of home in on the differential equation, then decide, is it dependent only showing, independent only showing, or do I see both? So all I see is the h in the h plus 7 to the 3rd. So that's the dependent variable only showing. And so I would sort it in that way. And there's actually 4 of each type. And then I ask you to do different things with the differential equation. Sometimes write the equation of the tangent line, sometimes solve and find the particular solution, sometimes just make a prediction or something. So there's a lot going on, and we might refer to this activity tomorrow, and we also might refer to the activity as we review for the exam. So we wanted you to have that there and make a hard copy of it if you can, or if you want to.
All right. And tomorrow, of course, we will be wrapping up Unit 7. We're going to look at some free responses, another activity actually that is from Brian Passwater, who's doing the BC ones in the morning, if you're somebody who's watching both videos. So I look forward to being able to brag on some of his work. And thank you for bearing with us during our little drop. I know I wanted to make sure Verge was gone before I stole the screen, and that creates some
before you
air.
talk bad about me, you mean?
Yeah. Oh yeah. Yeah, they got their joke for the day. I can't tell you.
Oh, I'm just gonna have to I'm gonna have to watch it in reruns.
No. Okay, so obviously there's the link to the Dropbox. It's in the description below the video. And once again, a shout out to, if you can get people tech, we still got at least a month to the exams. So there's plenty of time for people to get tech, get caught up, watch videos as they can. I think you can watch them on 2 times, which changes the timing of the video a little, but we are still audible at 2 times speed. So you can zip through the old videos if you wish to.
Good. Okay. And tomorrow is Friday, and we are wrapping up our Unit 7 tomorrow. So we hope you can join us for that. So until then, see you later.
Bye, everybody.
Bye, everybody. We love you.